So Tesla and its sometimes polarizing owner, Elon Musk, has developed the most efficient and reliable charging network in the world. Not surprisingly, the Society for Automotive Engineers just developed the J3400 standard for the North American charging standard, which is really the Tesla charger. Also, not surprisingly, Tesla is the largest EV automobile manufacturer that does not use the Open Charge Point Protocol. And OCPP will be a discussion in my session today. So I got involved with EV charging as part of a Department of Defense project and also with the state's National Electric Vehicle Infrastructure Policy. That was released a year ago today, or a year ago in February. And it set aside $5 to $7.5 billion worth of funding for all of the United States that wanted to submit requests for funding for their EV infrastructure. And the goal was to have, or is to have, charging stations every 50 miles within 1 mile of a major intersection, or what they call alternative fuel corridors. The other thing that NEVI did was it created this joint office of the Department of Energy and the Department of Transportation, because for the first time ever, DOT and DOE have to support their own combined infrastructure for electric vehicles. The unfortunate thing is that cybersecurity is not listed as a priority in the joint office of DOE-DOT for 2024. These are some of the terms that I'm going to use. I'm going to focus on the Open Charge Point Protocol because that's really the de facto standard for application layer protocol for the EV charging system to the back-end charging station management system. So I've gone through NEVI with a fine-tooth comb many times, and it sets aside 12 cybersecurity requirements. You see that Open Charge Point Protocol is a requirement for NEVI. So if I wanted to get funding for Tesla charging stations or whatever, I wouldn't be able to because I need to comply with Open Charge Point Protocol in order to get funding for my state out of the NEVI grant, which is $7.5 billion. It also requires the Open Charge Point interface, and that is the roaming version of the Open Charge Point Protocol. The other thing that it requires is a third-party testing and certification, which is a bit of a challenge when there's no certification body. So if I went out today to go certify an EV charging station network, I would ask, well, what is a standard? And there is none. There's no charging or testing and certification body for EV charging at this time in the United States. There's the rest of the requirements in NEVI, cryptographic agility. I think you've heard that term quite frequently recently because finally people are realizing that cryptographic algorithms don't stay the same for 50 years. They change with time. And so the other thing that is a bit of a challenge is that they're requiring conformance, I guess, or compliance with the usual slew of NIST 800 series guide specs, which have nothing to do with Internet of Things or IoT. Most of them are IT specific and have very little to no relevance in the OT world or Internet of Things world. The one exception, of course, is 882, which I'm sure you've heard about at S4 many times. And then they've also required PCI DSS, the Payment Card Industry Data Security Standard, which is great, and we should secure payment systems. But there is no standards body for the EV charging or the electric grid side of the EV ecosystem. You'll also notice 15118-2 is required. That's the comms protocol between the EV and the charging station. Again, Tesla doesn't play in that space. They're the only major automobile EV manufacturer that doesn't. So then we have, and all of these things I started to look at when I had my first project in 2021 to write proposals for a state for the NEVI funding. And they told me, we need you to know PCI DSS. And so I started looking and realized there's a lot more than PCI DSS here going on. It's a lot more than payment systems. So, and I do know PCI DSS, and I'm telling you, there's a lot more significant things that need to be looked at aside from payment systems here. You see there's probably about 9 standards groups on this graphic. The Open Charge Alliance in the middle is responsible for the Open Charge Protocol development and distribution, and they're out of the Netherlands. The United Nations even bought into this whole EV mobility cybersecurity, and they have Regulation 155 that's been issued. IEEE has 1547, IEC 6185. I mean, I could go on and on with the numbers, but the important thing here is that there are a lot of standards bodies that have to cooperate, and they're all from different sectors of the industry. You've got Society of Automotive Engineering having to cooperate with IEC, who does mostly electric utility things. So that's the challenge. And then this is an OSI 7-layer protocol stack for those of you that care. You'll notice that the Open Charge Point Protocol is at the application layer. And that's what I'm talking about today, is the OCPP, which sits at the application layer. Again, for everything except for the Tesla network. At the physical layer, we see cell modems being deployed most of the time in EV charging stations. There's all kinds of other options. There's this new IEEE 1901 Home PHY physical. It's actually communications over electric, and we don't see that. I haven't seen that at all. And then there's CHA demo that came from Japan, which is going to be end of life soon, I'm pretty sure, because of the North American charging standard that just got adopted, which is basically Tesla's charging standard. So this is a very oversimplified diagram. There are reference architectures that are quite more detailed, but just to break it down simply, between the electric vehicle and the EV supply equipment, which we call the charger, ISO 15118 is the communications protocol. And it's not just one standard, it's a series of standards, kind of like 62443. There's about 7 standards in ISO 15118. Right now we're on -2, but I'll talk about -20 in a minute. And the Open Charge Point Protocol provides application layer comms between the EVSE and the management system in the back end. So, the Open Charge Point Protocol, the key ingredient. It's open source, managed by the Open Charge Alliance in the Netherlands. If you haven't been to the OCA website, I would encourage you to do so. They've got a lot of information there, and they're a pretty easy organization to work with. It's a client-server model where the clients are the EV charging stations, and the server is the back-end management station. OCPP is delivered in JSON data format, and then the OEMs can take it and develop JavaScript or C++ or whatever source they want to develop. But it's delivered in JSON format. The largest deployment of OCP was version 1.6, and I'll talk about why that's important. So, OCPP 1.6 and 2.01, which is the version currently being deployed, they permit hard coding of credentials for usernames and passwords. There are several security profiles within OCPP, and you have the option to pick one that is not only HTTP basic, which means nothing is encrypted and clear text is sent, but you can also hard code your username and password in your software. And we all know that's a great thing to do, right? So the problem is that this was allowed as an option. And while some vendors will never do that, if you give people the easy button, they're going to take the easy button, especially when there's a rush to market. So there have been many large-scale vendors that have been tested, and we found hard-coded credentials in their software. We also found hard-coded SIM codes, the SIM identifiers that the phone companies use. We found that those were being hard-coded as well. And so the moral of the story is, don't do that. Stop hard-coding credentials. Okay, OCP 1.6. We talk about secure by design all the time and cyber-informed engineering, and apparently the OCA didn't get the memo because OCP 1.6 was intentionally delivered without security, no cybersecurity in the biggest deployment of OCPP in the world. I don't know what the reasoning was behind that. I mean, I can postulate that maybe it was because of this rush to market that we all seem to have lately, but we all know that's not a great idea to deliberately release a major deployment without security. So they followed that up a year or two later with a firmware update that added security. And the security they added was already out of date, right? It was TLS 1.2. They added event logging and secure firmware updates by doing hash checking in the code. But this was after the fact. So if I'm an EV vendor, and I have several friends that are in the business just because, there's nothing that is compelling me to upgrade, to update my firmware to make it secure. Nobody is telling me to do that. There's no standards body, there's nobody checking, you can do whatever you want. It's pretty much the Wild Wild West in EV charging at this time. So this is the feature set evolution of OCPP. So you see 1.6 started no cyber, no security at all, no secure connections, no secure firmware updates. Then 2.0.1 came around in 2020, and they added what they call advanced security. And what they mean by advanced is mostly the criteria that I just talked about. The big issue, though, is that 2.0.1 and 1.6 are not backwards compatible. So I'm an OEM vendor. I have charging stations out there. They're running 1.6. There is no compelling reason for me to go to 2.0.1 because I can't do over-the-air update. It has to be a forklift upgrade because the EVSE equipment can't manage 2.0.1. And 2.1 has now been delivered, or at least to the OCA members. And for 2.1, for 2.1 to be able to be accepted, I have to have 2.0.1 installed. So what that means is the vendors that deployed 1.6 are kind of in a bad place right now. They're going to have to do some major upgrades, and it's going to cost a lot of money for them because the end goal is to get to 2.1 right now. And 2.1 has included V to X, which is bidirectional charging. So there are a lot of very detailed reference architecture diagrams from the Renewable Energy Lab, from INL, from EPRI. This is not a detailed reference architecture diagram. What I did was I took all of the reference architecture diagrams I could find and mapped out the attack surface for EV charging. And as you can see, it's quite broad. It includes building automation systems. I think you were just hearing from a building automation system person. We also do building automation systems, and people are starting to ask us to include EV charging in their building automation system. So that is part of now the attack surface of EV charging stations. Also residential, right? Residential, people are having their electric panels upgraded to 200 amps or whatever to be able to handle EV charging in their garages. So your home can be an attack surface. So can the power grid. So can microgrids and the distributed systems operators. So I think we all hear about high consequence events quite frequently these days. And in terms of vehicle to grid or bidirectional charging, the high consequence events can send false demand signals to the power grid, and that destabilizes the regional grid depending on what section of EV charging stations you've affected. The real problem is with extreme charging stations because they take a lot of power, and sending false demand signals from those could really, really cause a destabilization of the regional grid. And this has been already tested in lab environments. Fortunately, we're not built out to scale enough right now for EV charging stations, so this isn't happening right now. It is something, though, that needs to be on our radar so that we can secure by design the rest of our EV infrastructure. In terms of the EV charging stations themselves, there's some cyber-physical things that we need to be concerned with. Again, the extreme fast charging stations, those are what is now being looked at for medium-duty and heavy-duty vehicles like your freight trucks, your buses, and other things. There's these temperature sensors on those extreme fast chargers, and they're very easy to manipulate. And when you manipulate those temperature sensors, what happens is it blows up, right? You cause a fire, and that has happened in a lab environment already. Buffer overflow attacks are depending on the source code that you're using to develop your charging station software with your OCPP JSON data formats. And so what cyber briefing wouldn't be complete without some kind of census or Shodan stats, right? We have a guy named Fred Gordy that works with me. He loves to play on census. And what he found just in a 5-minute search was 24,000 commercially exposed EV charging stations across the world. And so the moral of that story is stop connecting EV charging stations to the internet without protection. And we found, the vendors that we found, it's not one certain vendor. So I believe the problem is with system integrators as much as it is with vendors, because system integrators go out and plug these things in wherever they're needed. And so it's not a vendor-specific problem. It's the whole ecosystem is not being smart right now. It's kind of the wild, wild west. Okay, so I developed a set of 10 recommendations, and I'll go through them now. In terms of technology recommendations, I listed number 1 as the need to have a more sophisticated electric utility grid monitoring system, because I worked at an electric utility. For a few years, I developed and built the SOC and managed it in a NERC-CIP environment, and I still have nightmares tonight about it. I kid you not, because the things that we saw were shocking to me. Actually, they shouldn't be. I was in the military, but it's shocking that we can't monitor these things more intelligently. We don't have artificial intelligence algorithms deployed across the electric grid, and we need to get smart real quick. We just need to do better across monitoring our electric grid. The other thing for open charge point protocol that we need to realize is that TLS isn't the only security tool you should be using for this very important protocol. Whatever happened to zero trust and all of the different defense in depth layers and the hard shell on the outside and soft in the middle and all those parodies? We need to thank zero trust when it comes to EV charging stations. We're relying right now on TLS alone by itself, and that's not a good thing. We need to increase that capability. We need to not use hard-coded credentials in our software. I don't know if anyone here has ever been a software developer. The only time I remember using hard-coded credentials is in a lab environment when I was testing my product. I know I have never released a major deployment with hard-coded credentials. That's just insane to me. But we need to stop doing it because it's been done. And if you go look at CVEs, you'll see how CVEs were issued at a 9.8 score, blah, 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 because it had to be mitigated quickly. In terms of certificates, so a lot of the OEMs that are building charging stations, they're pushing the easy button and not using the client-side certificates. They're only doing certificates on the server side, the back end. And that's not going to work. We need certificates on both the client side and the server side. And if PKI is hard to implement, well, then we need to stop and figure out how to do it correctly. We can't just not secure our EV charging stations. The other thing that should be without having to say, but I'll say it anyway, we should not be connecting EV charging stations directly to the internet without some type of protection. I think you heard from my buddy Colin Dunn from Fend, a data diode would even be better than just a naked device on the internet. You know, a data diode, a firewall, VPN, anything that can protect that device, because that device is going to increase in capability over the next few years. Right now, we're okay, we're not at scale, but it's going to get bigger. Okay, so the problems with OCPP and EV charging are not just technical, they're policy as well. One thing is that we're using this open source software, right? It's open source OCPP. So Open Charge Alliance, I think, realizes that that's not being taken well. So they've petitioned the IEC to make OCPP an IEC standard. And what that would do is add funding, add brainpower, add testing, and all kinds of things. And so this is definitely a step in the right direction. The NEVI policy that was written in 2022 needs to be updated. One thing that needs to be added is a reference architecture. We can't build out an entire country, much less the world, of EV charging stations without a good reference architecture. It's like trying to build an entire housing development without an architect. So there is none right now. So if I go to Oklahoma and try to do some testing or assessments on their EV charging systems, it's going to be different than when I go to Iowa, because there's no single reference architecture being used. This is a giant fallacy that needs to be fixed as soon as possible. And I'm working with the ITS America group to get that added into NEVI as soon as possible. The other thing that needs to be done is adding test and certification body, as I mentioned. PCI DSS, it's a certification body. When somebody tells me, hey, we need to see if this FAIR system is PCI compliant, I have a little set of tools and I go check it out and I say it's either yay or nay. But when someone tells me, go see if this EVSE or EV charging station network is compliant, I have no tools. What am I supposed to do? Yes, the Open Charge Alliance issues a test harness in software code, right, for OCPP. But that's only part of the puzzle. I need an entire set of test standards to make sure that my EV charging stations are compliant with something that provides some sense of security. We need to start focusing on power grid protection. Sure, payment cards are important, they are. And I want my data protected just as much as anyone else. But I want my power grid protected too, because lives depend on that power grid. So we need to start focusing on power grid protections as much as we do on payments. Like I said, when I write proposals and other things, the states come to me and ask me to include PCI DSS compliance, but they never even think about the power grids that they need to protect. And lastly, we need to develop a good set of alarm standards across all of the electric utility sector for the EVSE system. So when I get an alarm, an anomaly in Iowa, I want to make sure that I know what that alarm means and how to mitigate it the same as I would in Texas. So those are my 10 recommendations, and I'll be working towards those in 2024. And what would a good cyber briefing be without a grad student? Emily Kessler, I wanted to thank her. She couldn't be here because she's a grad student and this costs a lot of money. She's going to be at an S4 near you, I hope. She's getting her master's in cybersecurity, and she's been working with me on electric vehicle infrastructure for about a year now. There's some references here. I wanted to thank Michelle Maggiore from Cisco. Her and I have written a couple of white papers together for ITS America about the lack of engagement on cybersecurity for the EV charging infrastructure. And I would encourage you to go to the Open Charge Alliance website if you'd like to know more information. This was just the tip of the iceberg. There's a lot more there. Okay, that's it. And anyone have questions?
Hi, thank you for the presentation. I'm new to the EV space. I just bought EV last year, so I'm learning all about this. And I'm just, I have a question about kind of where this open standard is going, because I've been seeing on the news where a lot of major auto manufacturers switching over to the Tesla networks.
Yeah. So that's a good point that you bring up. What that was about was the charging cable itself, right? So for a long time we said, oh, well, J1772 or whatever is going to be the standard. But then Tesla was very smart in withholding their design till the last minute. And then they said, oh, you want to use our standard? And then they made a deal with the Society for Automotive Engineer and DOT. And now the North American charging standard is the Tesla charger. And one of the reasons is because it's the fastest charger on the market, right? It's very reliable. But again, I mean, Tesla's great, but they have a closed network, right? Of course it's easy to make it the best when you don't have to work with anybody else, right? You don't have to play with anybody, so you can just make your stuff the best. That's how I see it.
Right. So my question is really, as more manufacturing are just signing up to Tesla because it's an easier thing to do, what is this organization doing going forward to kind of make a good selling point to kind of draw everyone back to
Yeah, so I think
standard?
the Open Charge Alliance realizes what's happening. And like I said, they are trying really hard to get their OCPP put into the IEC standard. So I think that we will see movement within the next year from the Open Charge Alliance, especially with version 2.1 coming out, because that includes bidirectional charging functionality. And that's not going to happen without IEC approving it. So I think it's going to become a standard, but it's going to go roll up into IEC. That's my prediction. It'll roll up into IEC, and then IEC will dictate out to the rest of the world. And so Tesla will probably play in that space as well. I don't know.
Thank you.
Thanks. Any other questions? Thank you. Thank you very much.